So we were talking about quadrilaterals, and in the last three videos we have seen the types introduction and the theorems or the results related to this chapter, quadrilaterals and parallelograms. So today we will see a few examples before starting to exercise 8.1. So let's proceed with the example 1. It's saying show that each angle in a rectangle is of 90 degree. So while doing the introduction, we have seen the types of quadrilaterals, in which we have seen what a rectangle is. Rectangle is basically, as I have told you, is a parallelogram in which at least one angle should be of 90 degree at the vertex. So how we'll do this question? So we know that rectangle is basically what? A parallelogram, and if this is my figure, this is A and B points, and these are basically two parallel lines. According to the definition of parallelogram, both the opposite pair of sides are parallel to each other. So if this is D and C, so this AD is parallel to BC and AB is acting as a transversal here. So I can write angle A plus angle B, both will give me a sum of 180 degrees. How? If these are two parallel lines and this is acting as a transversal, then these two angles are what? Co-interior angles, and the sum of co-interior angles is 180 degree when the two lines are parallel and intersecting by a transversal. Then sum of two angles is 180 degree. So AD is parallel to BC, so we can write the reason AD is parallel to BC, both are co-interior angles. Co-interior angles, or the angle made by transversal on the same side. So angle A plus angle B is equals to 180 degree. Here angle A is what? 90 degrees. I'll put the value here. So angle B is equals to, write the other things. So angle B is equals to 180 degree minus 90 degree. I'll reach to angle B is equals to 90 degree. So we have shown that angle A was with us 90 degree. We have shown that angle B is equals to 90 degree. Now we know that in a parallelogram, we have seen a theorem that opposite angles are equal to each other in a parallelogram. So ABCD is basically a parallelogram. So therefore we can write that angle B is equals to angle D. So automatically if B is 90, D will be is equals to 90 degree. Also, if you are able to see, if angle A is equals to 90 is given to us, so angle A is equals to angle C. A is equals to 90, so C will be equals to 90. Reason is what? Because opposite angles, not angles, I'll write opposite angles of a parallelogram are equal. We have seen a theorem along with its proof in the last video. So opposite angles of a parallelogram are equal, therefore these two angles will be of 90 degree, and this is showing that all the angles, rest of all the angles are 90 degree. This was what they are asking us to show. So this is the answer or proof for this example. Let's move to the next example. So the next question is show that the diagonals of a rhombus are perpendicular to each other. So we know that what a rhombus is. Rhombus is a quadrilateral in which all the sides are equal to each other. If this is my quadrilateral ABCD, then if all the sides are equal to each other and opposite pair of sides are parallel to each other, then it is forming a rhombus. We have to show that the diagonals of this rhombus ABCD, here all the sides are equal. Perpendicular to each other. This is diagonal 1 AC, diagonal 2 is BD. I have to show that these angles, I will not mention here, show here. I have to show this angle, these are all 90 degree. They are perpendicular to each other. This thing I have to show. Triangle AOD and triangle, this triangle AOD and triangle COD. This side is equals to this side. Fine. What else? OD is equals to OD is common. I'm going to write the reason. This side is common, and AD is equals to CD. What are the reasons why they are equal? Because we know that diagonal of a parallelogram bisect each other, means they are in equal length. These two lengths are equal because O is bisecting AC. OD is what? This is common side of these two triangles. This is common here. Why AD is equals to CD? Because it is a rhombus. Rhombus is given to us. Fine. So all these three are what? Side, side, side. So the corresponding sides of these two triangles are what? Equal. So by SSS criteria, by SSS rule of congruence, you can write, we have shown that triangle AOD is congruent to triangle COD. Fine. So these two triangles are what? Congruent. Now I have to show that the diagonals of rhombus are perpendicular to each other. So if I show that this angle is of 90 degree, we have done with the solution. So what I can do further? So this is a line. This is a line. These are two adjacent angles, basically adjacent angles with non-common arms as a straight line. So this is making a pair of linear pair of angles, basically. So I can write by SSS criteria, we have shown that these two triangles are congruent. Then by CPCT, why I have used this criteria to show congruence? Because I have to make use of this thing. By CPCT, I can write angle AOD. This angle is equals to this angle COD. By CPCT, we have these both angles equal to each other. Now these are making a linear pair of angles. We can write angle AOD plus angle COD. This is equals to 180, linear pair of angles. So as both the angles are equal, we can put the value here. I can write AOD as COD or COD as AOD. Let me write COD as AOD. So this I am writing. This is equals to 180 degree. From here, let me write here. 2 AOD I am getting 2 times angle AOD is equals to 180 degrees. Then angle AOD is what? Obviously of 90 degrees. Here I am getting angle AOD. This angle AOD is equals to 90 degree. Similarly, I have, because AOD is equals to COD, this angle is of 90 degrees. So COD is automatically of 90 degree because both are equal, which is giving me the result that the diagonals of a rhombus are perpendicular to each other. Why? Because this angle is 90, this angle is 90, further with vertically opposite angles, all the angles are of 90 degrees. So here these angles, these two diagonals are bisecting. Why? Because this is a parallelogram. We have seen a result that diagonals of a parallelogram bisect each other. Fine. Further, in a rhombus, condition is in a rhombus. In a rhombus, these diagonals are bisecting, but at 90 degree. This thing we have shown in this question. This is basically a result for rhombus. Example number 3. Statement is given, figure is also given, but I just want to tell you that if we are not given with the figure, we must be able to draw the figure from the statement if each and everything is given. Let me tell you how we will draw. ABC is an isosceles triangle. So we know that if a triangle is isosceles when two sides are equal. Which sides are given equal? With AB is equals to AC. These two sides are given equal. AD bisects exterior angle PAC. PAC, this is my AC. I have to draw P in such a way that AD, this is my A, so exterior angle. So if I extend this to point P, this is my P. So this is PAC and AD is bisecting. Somewhere AD will be like this because we are talking about a chapter which is quadrilateral. So it will make somewhere like here. PAC, AD is bisecting. This is my point DC and CD is parallel to AB. I have to draw CD in such a way that it should be parallel to AB. So this is my AD, given that CD is parallel to AB. So these two sides are given parallel. This is an exterior angle basically to this triangle to which AD is bisecting. So all these things we have in our hands. What we have to prove? We have to prove these two things. Let's check what is the first thing that we have to prove. Let me write what I have. I have ABC is an isosceles triangle. So basically given is AB is equals to AC. So if AB is equals to AC is given, we know the result of an isosceles triangle, that then angle ABC will be equals to, directly write, if something is given, write what you can derive from that thing. So ABC will be equals to ACB, but I'll take the name from the question BCA. I'll write BCA. So these two angles will automatically be equal when we are talking about an isosceles triangle with the AB is equals to AC, then these two angles will be equal. We have seen a result in the last chapter. Also, what is given to us that this AD is bisecting this complete angle. So basically this angle is equals to this angle is also given. So what else we have? Angle PAD is equals to DAC. These two angles are given equal to us, and we have to show. Let's see what we have to show. Rest, this is parallel to this is fine. We can write CD is parallel to AB is also given. All these things are given to us. DAC, this angle we have to show equals to BCA, this angle. So alternate pair of angles, basically if these are parallel, then we have to show these two angles equal. So what we can do with these things to go to the result that we have to show? So I can write, basically this is an exterior angle. If this is my triangle, let me draw, this is a triangle, this is exterior angle. So this exterior angle is sum of two opposite interior angles. So I can write this angle is equals to this plus this. So angle PAC, this complete angle, exterior angle PAC, can be written as a sum of ABC plus BCA. ABC plus BCA. Here you will write exterior angle sum property. Exterior angle sum property. Fine. So PAC further can be written as PAD plus DAC. PAD plus DAC. Why? Because AD is given angle bisector of this complete angle. So these two angles are equal, but this can be written as sum of this first. So this ABC plus BCA as such. ABC plus BCA. So DAC, I have to find the result in terms of DAC and BCA. So I'll write this PAD. PAD is equals to DCA because it is angle bisector. DAC plus DAC. This can be written. Why? Because it is angle bisector. Here I have to keep BCA. So I'll write this ABC as BCA. Why? Because this is given according to the question. This is also given. So I have reached 2 times angle DAC is equals to 2 times angle BCA. Fine. 2 can cancel out from both the sides. So we are left with DAC, sorry, not DC. DAC is equals to BCA. So first part we have proved. So let's see the next part where we have to show that ABCD is a parallelogram. Let me erase this. So it was given in the question that CD is parallel to AB. Now we have shown that this angle is equals to this angle we have shown. Let me draw this for you, that a pair of alternate interior angles is equal, which will give me further that AD is parallel to BC. So I can write as DAC is equals to BCA, alternate pair of angles. Then as AC is bisecting, acting as a transversal, AC is acting as a transversal, therefore AD will be parallel to CB or BC. CB. So this is a pair we have shown, alternate pair of angles equal. Then this line AD will be parallel to BC. And what else we have? It is given that CD is parallel to AB. So both the pairs of opposite sides are given parallel to it. This was given, this we have proved. Sorry, this was given and this pair we have just proved. So therefore ABCD is forming a parallelogram. Proved. Very simple, very easy. So I hope you understood. Let's see the next Example number 4. So see this example 4, it's very important. Example is saying that two parallel lines L and M are intersected by a transversal P. So what is this figure is given to us. This L line and line M, this is line M, these are given parallel to each other, and these two lines are intersected by this transversal P. So show that the quadrilateral formed by the bisectors of interior angles is a rectangle. So these were two parallel, these are forming a rectangle. These bisectors are forming a rectangle. Bisectors of what? Interior angles. When these are two parallel lines and this is a transversal, we know that we have four interior angles, and the bisectors of all these are forming a rectangle. This thing we have to show. So this is the given figure. So we have to show that A, B, C, D. These are angle bisectors. This means that this angle is equals to this angle. This is the meaning of angle bisector. So we have to show that A, B, C, D is forming a rectangle. So what we are having given L is parallel to M. Yes. So the other name for L is PS is parallel to QR. That is PS is parallel to QR. To show ABCD is a rectangle. Fine. Now we know that angle, if these are two parallel lines, this is a transversal, then this angle PAC will be equals to ACR. PAC will be equals to ACR. This is making a pair of alternate angles, alternate interior angles. So PAC is equals to ACR. Why? Alternate interior angles. Alternate interior angles or alternate angles. Pair of alternate angles. So if I put half on the both sides, nothing will change. So half of this will be equals to half of this. Why I am taking half? Because bisectors of these angles are given to us. So we will put half to get this angle. Half of this complete angle is what that I need in my rectangle. I'll take that one. BAC. I will not write PAB because this is of no use for me. I'll write BAC. So angle BAC will be equals to half of this angle that is falling in this rectangle. I'll write ACD. Fine. ACD. So these two angles are equal now. Let me erase the statement now. So BAC is equals to ACD we have in our hands. These two angles are equal now. We have shown these two angles are equal. When these two angles are equal, the line AB and CD will be parallel. Why? Because AC is acting as a transversal and the pair of these two angles are alternate pair of angles between these two lines. Then these two lines will be parallel. Here we can write alternate, same reason, pair of alternate angles. Pair of alternate angles between which and which line? Between AB and CD. Therefore, we will have AB is parallel to CD. Fine. So similarly, we can write we can show that what else? This BC is parallel to AD. Similarly, we can show that this is parallel to AD. When we have shown that opposite pairs of this quadrilateral that is forming are parallel to each other, then this means this is forming a parallelogram. We have reached to the result that ABCD is a parallelogram. To show that this is forming a rectangle, first need was to show that this is forming a parallelogram, and if we show any of the angles at the vertices of ABCD is of 90 degree, then it will be a rectangle. It will be proved. Now to show any of the angles at vertex or at the vertices of this ABCD is of 90 degree. How we will show this? So we know that angle, you can write, we know that this angle PAC plus angle, what else? CAS. CAS or SAC we can write. So angle PAC plus CAS, these two angles are forming a linear pair of angles. Yes, this is a line, this is a transversal, or we can say these are two adjacent angles with one common arm and the rest of the two arms are non-common. So this is making a linear pair of angles. So their sum is what? 180 degree. Fine. So PAC plus CAS. If I put half on both sides, half of PAC plus half of CAS is equals to half of this 180 degree. So what is half of PAC? Half of half of this is ABC, because this is an angle bisector. So BAC I'll write. So half of PAC is what? BAC. We have written here also, plus half of CAS. Half of it is CAD. This is equals to what? 90 degree. So we have shown that this angle plus this angle means this complete angle A, that is BAD. We have shown BAD, this is forming BAD, is equals to 90 degree, which is what? An angle at a vertex of this parallelogram have shown of 90 degrees, which is giving us that ABCD is a rectangle, which is enough to prove that ABCD is a rectangle. So we can write as ABCD is a parallelogram with angle A is equals to 90 degree. Therefore, ABCD is forming a rectangle, is forming a rectangle, hence proved. A good question it is. So it is also important. So these were the 4 questions for today. In the next video we will see a theorem and rest of the examples, and we'll try to start with exercise 8.1. Till then, study hard. Do well. Thank you for watching.